So yeah, today I'll be talking about coroutines and like how I imagine they would work in Qt. There's been a few things already internally, but nothing ever like materialized inside of like a released version of Qt. So my name is Mårten. I've been at the Qt company for 6 years, starting in April. So I was an April Fool's joke. And at that time, I got on to become the maintainer of Qt Network, and then more recently, the co-maintainer of Qt WebSockets. And because networking is a lot of waiting, so of course that means there is some interest in asynchronous code. As a quick intro, what are coroutines? Coroutines fit into the definition of cooperative multitasking, which is kind of the idea that instead of having your program just block on something or having your thread block on waiting for a file or network, you can just relinquish the thread and let it do something else while the operating system does whatever you requested in the background. Of course, that's not a big problem in Qt because Qt is designed for asynchronous or like single-threaded workloads in like mostly. So in like, for example, network, we have a separate thread in the background that you don't have to care about, and it just gives you the result when it's ready. Specifically for C++, there are some requirements for a coroutine. For one, the return type needs to have like specific functions available because the compiler will generate some calls to those functions depending on like what you're calling. If you're doing like co-await or co-return, if your coroutine returns void, it will call a function called return void in on the like promise type of your return type. I'm not going to go into like the specifics of like every callback that is needed or every function that's needed, but yeah, for example, like co-await is used with an awaitable object, so you will say like co-await some awaitable, like Piotr mentioned earlier. Something like QFuture would make sense, which is very similar to standard future. There you would just wait for the future to be set to finished, and then you will just return the result immediately to where the coroutine is, and it will suspend when you call await, and then it will resume it once the result is ready. Then there's co-return, where you can return from the coroutine. If it returns void, then you don't have a value at all, right? But if your coroutine returns a type, then you need to return a value. And then there's co-yield, which is used for generators. It will also return a value, and it will suspend the coroutine, but it won't end it. So it doesn't terminate or destruct anything. It can resume again later to run and return or yield a new value. So yeah, in Qt, as we mentioned earlier, there is QFuture and there's QPromise. It's not widely used by Qt itself, but if you're familiar with Qt concurrent, a lot of its types or a lot of its functions are returning QFutures. So then you could await QFuture in your coroutine, and it would resume your coroutine as soon as your concurrent function is ready. And then we also have somewhat more recently in Qt 6, you have Qt Future Connect, where you can create a future which is finished once the signal is emitted. So then we already have this, like you can await for signals to be emitted. So you can easily write synchronous looking code that's still waiting for signals. But yeah, there are some problems with QFuture if you want to use it as the return type for coroutines, because QFuture, of course, it's tailored towards use in UI. So we have this concept of QFuture specialized for int can have multiple results, unlike in like standard future where you would have to say vector of int, and then you return the whole vector at once. But in Qt you can return them like as you go, which doesn't really mesh with coroutines. You could consider it for generators, but then what is it doing for a normal coroutine? It's a little like there's some questions around that.
It's yielding values. That's what it's doing. In the coroutine model, it's yielding.
In a normal coroutine, you would, when you do coreturn, it destroys the coroutine and returns to one value. But in a generator, you can use multiple values.
Yeah.
Yeah, and then QFuture also has like progress and progress text, which how would you set those from a coroutine? Or would you like have a global function somewhere that you have to call, and then it gives it back? Yeah, it gives you the promise type back. Like there's some questions around that. So it might make more sense to have a dedicated return type, or see what happens in the standard, which seems to be going towards executors, but that's quite a different thing. And then QFuture also, somewhat also more recently, has continuations with .then, .onCancel, onFailed, which lets you pass in a functor that gets run if it gets cancelled or is finished or has an error, which also is kind of strange to have in a coroutine, because instead of having then following the coroutine, you could just have the coroutine call another coroutine and await it, and then you call the next thing instead of like chaining things with then calls. So yeah, why care about coroutines? Well, it's subjective, but it lets you write very linear looking code, even though it's suspending and resuming as things happen. Like in this example, CoFoo waits for code download, and then once the download is actually done, we get the data back, and then we can process it afterwards. So on line 5, the actual download will be awaited, and once we call that, it will actually suspend the code download, and we wait for the finish signal, and then we jump back to line 16 where we called code download, and it will wait for code download to finish, so it also suspends CoFoo, and then we go back and we eventually hit the event loop, which then just runs all the events through the system, and eventually we emit the finish signal, and it resumes code download, which then reaches one of its code returns, which then resumes CoFoo, and then it does its work. Which is quite nice. So it's kind of for reference, if you wanted to write this with the same semantics, where download handles all the download and also handles errors by turning the byte array into an empty string whenever there's an error. Then we also need to have like a callback, because that would be how we resume our previous logic, if you want to have foo also still contain the call to process. I mean, in a more realistic implementation, you might just do the call to network reply or to the network access manager inside foo, and will compress it to get it a little more, but then if you wanted to have download as a shared function that always does this error handling, then this is like one way to do it, even though it's, yeah. You can also do more of a Qt-like thing and have download the class and have it as a signal that goes out with error handled data. Yeah, and then there's generators. With coroutines we also have generators. And with generators we can avoid having all the work having done up front, which is good for things like Q-string tokenizer, which is it was originally written with the coroutines in mind, and it does work in the same way, but it's not like a stack. It's not actual coroutine. It just stores its state and then it just searches for the next substring. So it's like a string splitting facility. But yeah, like it doesn't like generate the full list and then return it. It just does the work as you iterate forward through it. So that would be a nice fit to make into a generator of some sort. So you could use it in a for loop and just loop over it. And then QObject find children is it's a bit of a specific example in Qt, but it lets you search through all the children and grandchildren in a QObject hierarchy. And it lets you also do that with matching a name with a regular expression. So it can be somewhat expensive. But if you don't actually care about having the full list up front, it makes sense to loop through it as you go instead of like doing all the work at once. And then if you combine it with ranges, you could also filter further on the few results you return back. And then it's more of a the last point is more of a thing that would be nice, and not something that already exists that could be better, but something that could be done somewhat easily with generators. Is having something like a by chunk or by line for IO device, where you can then loop over the output of a QIO device, like a network download or a Q file read. So if you say like, oh, I want to process this file by line, or I want to process it by chunks of some amount of bytes, which is quite possible in certain protocols and certain file types, like in HTTP1 headers, where every header is delimited by a new line, and then you just loop until you find a blank line, which is the endo header delimiter. I was afraid I would overrun.
No, it's fairly accurate. What else?